Yes, so hello everybody. I'm Emma Severance and I am the St. Louis County intern this summer, and I am a student at the University of Minnesota Twin Cities. So I have had the opportunity to have Kyle Roseman is one of my professors in the past. That's really cool to see him here tonight. And so yeah, I'm going to share first the forage testing video with you, and then we'll go into Tara's video of how to interpret those results.
Hello everyone, my name is Tara Young with the Carleton County Extension Service.
And I'm Emma Severance, the St. Louis County intern.
And today we are demonstrating how to take a forage sample on a dry, round hay bale.
It is important to get a representative sample of your forages so you can determine the nutritional value of these forages. To get this representative sample, you must follow these few steps.
Use a properly sharpened bale core sampler to reduce sampling error. An 18 to 24 inch long bale core sampler with a diameter of 3/4 of an inch wide. This ensures you get enough of the forage sample to submit it to the lab. Sampling without a bale core will result in an erroneous representation of stem versus leaf material. To get a representative sample, it is important to mix a minimum of 12 cores per lot. A lot is a group of bales that are expected to have similar nutrient composition. For example, all of the bales from a single field harvested on the same day. After collecting the forage sample, place the cores in a clean plastic bag. It is important to label your bag properly with your name, location of the field you collected the sample from, and the date. Remove as much air as possible and seal the bag tightly. Vacuum sealing is highly recommended for samples that are unstable, being shipped long distances, or for an analysis susceptible to changes during fermentation. Another way to collect a forage sample is to take a sample from the forages after cutting them. Again, it is important to take a minimum of 12 forage samples per lot to get a representative sample of your forages. Going around your lot and picking up samples from different areas of that field will help to do this. You can also take a forage analysis from your growing forages by cutting a sample from your field. You will need a sharp scissors to do this. Take and cut a handful of forages at the length you would normally cut them for baling, which is about 3 inches from the ground. Take samples from different areas of your field to maintain that representative sample. The last thing you would need to do is fill out the sample submission form from the representative laboratory and send the form along with your forage sample in to be tested.
At the end of the day, it is important to analyze your forages for the economic viability of your cattle operations. If you have any questions about this process, please feel free to contact your local county extension agent. And that was that video. And I should mention real quick that these videos were originally created for a beef webinar that we were working on, but all these things also relate to sheep and goats as well when talking about these topics. And next I have Tara's video.
How to analyze a forage sample test. Let's start by figuring out how to fill out the forage sample submission form, which test to select. Choose the lab that has the results layout you prefer. You'll see a little bit more of this later on in the presentation. Look at each package to see what is tested. Is it the most basic test or is it more advanced? And finally, look at it if it is a NIR or wet chemistry test. Now, what is the difference between NIR and wet chemistry? Feed analysis labs will usually offer 2 types of analysis. Near-infrared reflectance spectroscopy, or NIR, is a rapid, reliable, low-cost, computerized method to analyze feeds for their nutrient content using large databases of other samples for reference analysis. Now, wet chemistry analysis is the direct analysis of nutrients. It is more expensive and takes longer, but it is also more accurate. For beef cow nutrition, this is not necessary for forages. Grains and coal products are recommended to use this analysis because NIR is not accurate enough to predict nutrient composition of these types of feeds. Wet chemistry should be used when it is not a typical sample, i.e. really poor quality or an unusual forage source mix like oats, barley, rye. Now, what do the results mean? These are the components of a nutrient analysis report. The first component I will be covering is moisture and dry matter. Moisture is the water in a feed or forage. Having the correct moisture levels in forage is important to determine the storage potential of that forage and to minimize quality losses. Feed rations and value of the forage should be based on dry matter, since that is the usable portion of the feed. The animal uses the nutrients on a dry matter basis. Dry matter also makes ration building easier because it lets all feeds be compared to on the same basis. The next component I will be covering is crude protein, or CP. It is based on the nitrogen content of the feed. It is 6.25 times the nitrogen content. Any nitrogen will be considered in the total calculation of the protein. Acid detergent fiber, or ADF. This is the least digestible portion of the feed, made up of cellulose, pectin, and lignin. The greater the ADF value, the more indigestible the feedstuff. ADF is used to calculate the total digestible nutrients, TDN, or the energy value of the forage. Animals require a certain amount of energy, or TDN, based on their age, weight, and physiological state. The more ADF content in a forage, the less energy value it has, and vice versa. Understanding the inverse relationship ADF has with TDN can allow producers to determine whether energy supplementation will be required when feeding that forage, and it can help them understand why TDN is so high or low. Neutral detergent fiber. The little a in front means that the NDF portion has been treated with amylase, which makes sure there is no starch contamination. From here on out, I will refer to this as NDF. Neutral detergent fiber represents the total fiber content of the feedstuff, both indigestible and slowly digestible. The higher the NDF content of the feed, the slower the rumen passage rate. Typically, this is used to help predict intake by animals consuming the feedstuff. As NDF increases, intake is expected to decline. More time spent on rumination means less time on feed intake. The forage may meet requirements based on protein and energy content, but as NDF increases, the animal may not be able to consume enough of that feed to meet requirements on a pounds per day basis. So, NDF is an important value to understand in order to determine if the animal can consume enough of the forage to meet nutritional requirements. Unlike ADF, it has no bearing on quality and digestibility. Legumes tend to have lower NDF and ADF values than grasses, and increasing forage maturity raises NDF and ADF values. Now, the next component we'll be looking at is neutral detergent fiber digestibility, NDFD. This is an incremented measurement of NDF fiber digested in the rumen. Efficiency and rate of digestion are both measured in this calculation. As NDF is associated with the slowly digestible portion of the feed, measuring the digestibility of the NDF portion can allow a producer to determine how much of the NDF is indigestible and how much is slowly digestible. The portion of your forage sample that is NDF is immersed in a buffered rumen fluid to try to replicate the rumen environment. Then the digestibility is measured at 24, 30, and 240 hours. This gives us 3 pools of digestion rates. That which is in the less than 24 hours is rapidly turned into energy. The slower pool that falls between the 24 and 30 hours is only slightly digested. That which is in the 240-hour pool is basically not digested at all. So So in using these 3 points of measurement, we can determine the rate of digestion and, just as importantly, the rate of passage through the cow. The slow pool and the undigested portion are the indicators of gut fill, and that is what limits the total dry matter intake. So the more NDF we have that falls in the greater than 30-hour digestibility measurement, the less our cows can physically eat. Ash is another component I like to look at as well, because that is basically the soil contamination from harvesting. It should be in around the 10–11% mark. Now we are looking at forage quality. Forage and feed chemical composition is useful in assessing forage and feed quality, but it is the response of the animal that ultimately determines forage and feed quality. Palatability refers to how acceptable a forage or feed is to an animal. In lower quality forages, palatability and intake can become an issue. RFV, the relative feed value. The relative feed value accounts for an animal's expected forage intake and its energy value. RFV estimates digestible dry matter, DDM, from ADF and calculates the dry matter intake potential from NDF. It is the index value that ranks forages on ADF and NDF as compared to full bloom alfalfa, which is assigned an RFV of 100. The RFV method has a few limitations. First, RFV is calculated using only fiber values. Though protein certainly affects the value of hay, it has no effect on the calculation of RFV. Digestible dry matter and dry matter intake are assumed constants for all forages. Now, RFV was initially developed for the dairy industry to help rank the potential energy intake of different hays by lactating dairy cows, and it does this quite well, especially for legumes like alfalfa. Grass hay, however, is more difficult, as it has more fiber than alfalfa, which lowers the RFV. That fiber, however, often is more digestible than alfalfa fiber. Thus, grass hay frequently is ranked lower than it should be using RFV. Cattle will sometimes perform differently even when fed forages with identical RFV values. Variations in the digestibility of the NDF fraction can probably account for these differences. Now, relative forage quality, RFQ. Relative forage quality is similar to RFV, but uses TDN in place of DDM in calculations. Because RFQ calculations include digestible fiber, the RFQ index better reflects the performance that can be expected compared to the RFV. One other advantage of the RFQ prediction is that it differentiates legumes from grasses. Relative forage quality is appropriate for use with all forages except corn silage. Moving on to energy calculations. In energy calculations, the ORDAC calculations assign digestibility and energy values to crude protein, neutral detergent fiber, fat, and ash. So it is the most commonly used energy calculation. Selecting the package that includes ORDAC will be important for energy calculations if that is the calculation you prefer. Total digestible nutrients, or TDN, is an estimate of the energy content of the feed. It is calculated by a formula that uses ADF, NDF, crude protein, and ash components of the feedstuff to give an estimated value of energy. Typically, the greater the value, the more energy dense the feedstuff is considered. Typically, lower quality hays are in the 40 to 50% TDN range, while higher quality hays are in the 50 to 60% TDN range. In some cases, certain hays and legumes can be in the 60 to 70% TDN range. Most beef cattle producers evaluate the energy content of forage and feedstuffs based on TDN. TDN can be used as a guide with regards to energy. Now, net energy is a system that has been developed that allows more precise calculation of specific rates of gain and specific milk quantities produced. This system accounts for energy losses from digestion on different feeds, for which the TDN system does not account for. The net energy system allows for partitioning of nutrients based on stage of production. It allows for energy to go towards maintenance or production, or lactation or gain. Now, net energy of maintenance, the NEM, this is the amount of calories per pound of feed that will go towards maintenance of the animal. This is a more accurate estimate of what energy is available to the animal. There is also NEG and NEL. NEG is the net energy for gain. It is the energy used for productive purposes, including the deposition of protein and fat. NEL is the net energy for lactation, and it is the energy needed for milk production. And that was a brief overview of a forage sample result. On this results page, I changed the numbers a bit so you could see the importance of a few things. First, it is very important to note the correct type of forage. Is it dry hay, or is it ensiled, and plant type, legume, grass, corn? So it is the most accurate benchmarks that can be shown. Components such as pH will only be shown for ensiled forages, so selecting the correct test will give you the numbers you need. Being careful and filling out the needed information on the form will go a long way. Another important aspect is to show the difference in dry matter, in dry hay versus ensiled hay. Remember to analyze each component based on dry matter. Here I wanted to show you another test so you could see the layout differences between laboratories. This lab groups its tests into sections: proteins, fiber, carbohydrates, minerals, and energy calculation. Selecting whichever one you prefer will make it easier for you to analyze the test. Estimating dry matter intake. Now, using the forage test results, we can determine daily dry matter intake. Let's say we have a forage sample come back with a TDN of 46% and crude protein of 10%. This hay sample would fall into the medium quality hay due to the TDN content. If the cow herd average body weight is 1,200 pounds, then the expected maximum dry matter intake of hay would be 24 pounds per day. From this number, we can determine if the forage meets our nutrient requirements. Now, as a summary, more digestible forages and feeds pass through the rumen faster and allow for more forage and feed intake. And without knowing the quality of the forage we are feeding, it becomes difficult to balance a ration to make sure the animals are receiving the proper amount of needed nutrients. Please let your local extension educator know if you have any further questions. Thank you.
So now those were the videos that we had planned to show you guys. I will turn the conversation back over to Troy.